Hello, I'm going to talk you through the magic of trigonometry, and then you can practice by doing the self-checking exercises on the Transom website. So let's start off with the triangle. This triangle has got an angle of 90 degrees. You can see it there, a right angle marked with that little square. And what I'm going to do is focus on one of the other angles, this angle here. And then each of the sides of the triangle has got a specific name. So the one furthest away from the angle that I'm focusing on is called the opposite. And the one next to the angle I'm focusing on is called the adjacent. And the longest side of the right angle triangle, the one furthest away from the right angle, is called the hypotenuse. So you need to know these names really well, whichever way around the triangle is. We have the adjacent, the hypotenuse, and the opposite. So let's have a closer look. Hypotenuse, opposite, adjacent. Okay, you really need to know these names very, very well. So I'm going to give you a little challenge. I'm going to show you some triangles, all right angle triangles, but different ways around, and there's going to be a big red arrow pointing at one of the sides. And what you have to do is name that side. Now, if you really want the challenge, you can play the video with the volume down low so you can't hear me saying the answers. And then play that bit of the video back again so that you can hear me saying what the right answers are and that you know you've got them right. Okay, here we go. 1, 2, 3. That's the hypotenuse. It's the longest side of the triangle. That's the opposite. It's the side furthest away from the angle that we're focused on. That's the hypotenuse. It's the longest side of the triangle. That's the opposite. It's the side furthest away from the angle that we're focused on. That's the adjacent. It's the side next to the angle that we're focused on. That's the adjacent. It's the side next to the angle that we're focused on. That's the opposite. It's the side furthest away from the angle that we're focused on. That's the hypotenuse. It's the longest side of the triangle. That's the adjacent. It's the side next to the angle that we're focused on. Okay, now there is a little activity that you can do just to make sure that you really know the names of these sides well. The address is right there in front of you. Have a go at that exercise and then come back to this video when you've done that. Okay, what do you notice about these similar triangles? Well, they're definitely similar because they have got the same angles. They've both got a right angle in the bottom right corner. They've both got an angle of 60 degrees in the bottom left corner, so the other angle must be equal as well. Now, can you see that the base of these triangles is always half of the hypotenuse? So that's the adjacent down there next to the angle. The adjacent is always half of the hypotenuse. That's a useful fact for right angle triangles with that angle of 60 degrees. So let's use that. Here's another triangle. It's a right angle triangle. It has that angle of 60 degrees. And we can see that the adjacent is 9. So how long would the hypotenuse be? Well, the hypotenuse will be 18 because the adjacent is always half of the hypotenuse for right angle triangles that have an angle of 60. That's trigonometry. We've used that fact that we know about the ratio of the adjacent and the hypotenuse to solve a problem. What about these triangles? Well, they're similar as well, but this time I can see an angle of 30 that we're focused on, and I can see from the green triangle that the opposite is half of the hypotenuse. So the other similar triangle, that ratio must be the same. The ratio of the opposite and the hypotenuse. So I think the hypotenuse of the red triangle must be 16, because 8 is half of 16. Oh, what about this? What is the length of this hypotenuse? Well, this right angle triangle has got an angle of 28 degrees. And we haven't seen any other similar triangles so far with an angle of 28 degrees. I wonder what the ratio of the opposite and the hypotenuse are for this type of right angle triangle. Well, this ratio is called the sine ratio. It has a name, and it's the ratio of the opposite and the hypotenuse. If only we knew what that ratio was for an angle of 28 degrees. Well, in the past, a long time ago, people worked out these ratios for all the different angles you can think of and published them in books. In fact, when I went to school, I had a book a bit like this that told me the sine ratio for the angles. But nowadays we have calculators, and the calculators have got a sine button, so we can find out that ratio for any angle that we're interested in. So let's formalize it. The sine of an angle is the ratio of the opposite to the hypotenuse, and it's usually given as a fraction rather than as two numbers with a colon between them. What you have to remember is that this sine ratio, and the word sine is usually abbreviated just to SIN, this sine ratio is the opposite divided by the hypotenuse. That's a way of giving a ratio as a fraction, the opposite divided by the hypotenuse. Now, you need to memorize that. The sine ratio is the opposite divided by the hypotenuse. Have you got it? Here we are. The opposite divided by the hypotenuse is the sine of that particular angle. And that's called the sine ratio. Okay, while we're into memorization, here are some other trigonometric ratios for you to learn. There are 3 of them. The next one is called the cosine ratio, cosine. And that's usually abbreviated just to cos, C-O-S. And that ratio is the adjacent over the hypotenuse. The adjacent divided by the hypotenuse gives you the cosine ratio. You need to memorize that one as well. And here is the last one, the tangent ratio. That is the ratio between the other 2 sides that we haven't compared yet, the opposite and the adjacent. So the tangent ratio is the opposite divided by the adjacent. Wow, that's a lot of remembering that you're going to have to do. Let's think of an easy way to do it. Let's just look at the letters involved in the first ratio. The sine is the opposite over the hypotenuse. So we have the letters S, O and H. And for the second one we have the letters C, A and H. And for the third one T, O and A. And if we put them together, it makes a word. A magic word. Just like a magic spell. So if you can remember this word, that might help you remember these 3 trigonometric ratios. SOHCAHTOA. So you could pronounce this as SOHCAHTOA. 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 Okay, that might help you. You might want to pause the video here and make a note of all this that you have to memorize. So let's see if we can put that to use. Here we have our right angle triangle, and I can see an angle of 28 degrees. I can see the opposite is 12 centimeters long, and We don't know how long the hypotenuse is. We have to work it out. So at the moment, let's just call it x. So this is how you do trigonometry. The first thing is you recognize that it's the opposite and the hypotenuse. Now, which of our trig ratios involved the opposite and the hypotenuse? It was the sine ratio. The sine ratio is the opposite over the hypotenuse. So that's the first thing you have to work out, which ratio it is. And then you can write that down, putting in the measurements from the diagram. The sine ratio of 28 degrees is equal to the opposite divided by the hypotenuse. And that gives us an equation with one unknown that we can work out. And it would be helpful if we rearrange that equation first. So what I'm going to do is multiply both sides of the equation by x. And then I will divide by both sides of the equation by the sine of 28. And now I've just got one calculation that I need to do on my calculator in order to work out the length of x. So I'll type it in using the fraction function on this particular calculator. 12 divided by the sine of 28, and I get the answer 25 point and lots of digits as the decimal part of the answer. Well, I'll round that off to 3 significant figures. And my final answer is that the length of the hypotenuse is 25.6 centimeters to 3 significant figures. I'll look back up to the diagram. I can see it's not drawn to scale, but I'll ask myself, is that a realistic answer for the answer to that question? 25.6, if the opposite there is 12, could the hypotenuse be 25.6? Well, 28 is quite a small angle, so yes, I can believe that could be true. Okay, one more time. Here are the 3 trig ratios that you need to memorize. The sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. The word that helps us remember those ratios is SOHCAHTOA. 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 Okay, let's try and do some problems. Find the length of CB. CB. It's a right-angled triangle. And we have the length of this side, and we also have an angle. So the first thing we know, it's not Pythagoras because it involves an angle. And Pythagoras theorem questions only involve the lengths of the sides. So the first thing that we'll do is we'll label the sides that are involved in the question. It says find the length of CB, and I can see that CB is the hypotenuse. And it gives us the length of AC, and compared to this angle, that side is opposite. Okay, we have the 2 sides involved in the question. I know you know the name of this side, but we're not going to write it down because that'll just add complication. Now we say the magic word, SOHCAHTOA, and that should remind us of the ratios. And which of the ratios involves the opposite and the hypotenuse? I can see opposite and hypotenuse here, so that is the sine ratio. And what does that mean exactly? Well, it means the sine function of an angle, which in general people write down using this Greek letter called theta. So the sine of this angle, whatever it is equal to the opposite divided by the hypotenuse. So the next step is to put in the information that we've got on the question. So the sine of 25 degrees
is equal to the opposite, which I can see is 17 meters. I'm going to leave off the units and I'll just put the units in at the end. It just gets rid of some of the clutter. And that's divided by the hypotenuse. And the hypotenuse, CB, is what we're trying to find. So I don't know what that is yet. I'll just put it as CB. So now we have an equation with one unknown, one thing unknown that we need to find out the value of. So what I'm going to do is solve this just as I would equation. With any equation, I'm going to make this the subject. So I'm going to multiply both sides by CB, because at the moment this side is being divided by CB. So I'll do the opposite. CB multiplied by the sine of 25 degrees is equal to 17. And then, to leave CB as the subject here, I'm going to divide both sides by the sine of 25. And now I go to the calculator to solve that. So I'll turn the calculator on. I'll double check that it's in degrees mode, which I can see on this calculator. It's a very, very tiny little letter up there. And then I can use, well, this calculator has got a fraction template that I can type in the 17, and then using the sine button, and notice it's opening brackets for me to put the angle in, the 25, so I'll close those brackets. There it is, exactly as in my working. So what I can do now is press equal sign to get the answer. So the answer is 40 point, and then there's a long decimal after that. So what I'm going to do is I'm going to give my answer to 3 significant figures, which is the standard for any question unless you're told otherwise. And then I'll remember that the units we're dealing with are meters. And then I'll underline my answer. And then I'll say 2, 3 sig figs, which is my shortcut for saying 3 significant figures. So the final step is to look back at the question, back at the diagram, and even though the diagram wasn't drawn to scale, does 40.2 seem reasonable for the length of CB? Well, if that's 17 and that's a very small acute angle, I guess this could be quite a long side, 40.2 meters, so I think I've got the answer right. Okay, let's practice another question. Find the length of AC in this right angle triangle. So remember the routine. The first thing you do is label the sides involved in the question. So compared to that angle, this side here is the opposite. And the given side, this length here, is the hypotenuse. So now what I'm going to do is I'm going to say the magic word SOHCAHTOA, and that will remind me of the 3 trig ratios. I've got to work out which of these involves the opposite and the hypotenuse, and yes, it is the sine ratio again. So this time I'll go straight to putting the values in that are involved in the question. So I know that the sine of 26 degrees is equal to the opposite over the hypotenuse. The opposite, AC, that's what we're trying to work out, over the hypotenuse, which is 23 centimeters. I'm going to miss out the units just for now to avoid the clutter, and then I'll put them in at the end. Now I want to make AC the subject of this equation, so I'll multiply both sides by 23. So 23 times the sine of 26 degrees is equal to AC. That's going to be done on the calculator, and here we go. Let's clear anything that was there. So 23 multiplied by the sine, and it's open brackets ready for the angle, and the answer is 10.08 something, so I'm going to put that as 10.1. And then the units were centimeters. I'll underline that, and then finally I'll just check on the diagram. Does that look reasonable, that this length could be 10.1 centimeters if that's 23? Yes, that does seem a reasonable answer. Okay, for this question we have to find the length of CB. CB. Compared to this angle, this is the adjacent. So I'll write it on the diagram here. And the other side that's involved in the question is the hypotenuse. Now say the magic word, SOHCAHTOA, and we'll see which of these ratios involves the adjacent and the hypotenuse. It's clearly that one, the cosine. So I'm going to write down for my working that the cos of the angle, 33 degrees, is equal to, and it tells me it's the adjacent over the hypotenuse. So the adjacent is the CB that I'm trying to work out, and the hypotenuse is the 65 millimeters. We'll leave the units till later. Multiply both sides by 65. And then go to the calculator to work out that CB is 65 multiplied by the cos, and there's the cos button there, of 33 degrees. I'll close those brackets to keep things nice and tidy. And I get the answer 54.5. The units were millimeters this time. Finally, look at the diagram. Does that seem reasonable? 50, yeah, that's 65, so that could easily be 54, and that is to 3 sig figs. Find the length of AB. Compared to that angle, that's the opposite. I'm going to speed things up and just write over opposite, and the given side here is the adjacent, and the hypotenuse doesn't come into the question at all, so let's not label it. So we have opposite and adjacent. Say the magic word, SOHCAHTOA. Opposite and adjacent. That's the tangent ratio, which is over there. So we can write down the tan of the angle, 70 degrees, is equal to the opposite over the adjacent. The opposite is AB that we're trying to work out, and the adjacent is 13, saving our units for later. Multiply both sides by the 13. And I get 35.7 centimeters. And look at the diagram. Does that seem reasonable? Quite long. Well, that's a big angle, yeah, so that could be quite long, isn't it? To 3 sig figs. Find the length of AB. AB is definitely the hypotenuse here. And the side we're given is this side here, which compared to that angle is the adjacent. So, say the magic word, SOHCAHTOA, and I can see that adjacent and hypotenuse, it must be the cosine ratio. So the cos of 27 degrees is equal to the adjacent over the hypotenuse. The adjacent is 22 over the hypotenuse, which is our AB that we're trying to find out. Let's multiply both sides by AB. So AB times cos 27 degrees is equal to 22. And then to leave AB by itself, we divide both sides by the cos of 27 degrees. So now go to the calculator. I could use my little fraction template, or I could do 22 divided by the cosine of 27, and I get the answer 24.7. Find the length of CB. CB, that is the adjacent, and this given side is the opposite. Opposite and adjacent. SOHCAHTOA, magic spell, and we have opposite and adjacent. It is the tangent ratio. So I can see that the tan of 34 degrees is equal to the opposite over adjacent. So that's 235, and the adjacent is this side here, CB. Multiply both sides by CB. Divide both sides by tan 34. Calculator, and I get 348. Now, trigonometry can also be used to find the size of an angle. CAB. CAB, that means the angle up there. So I'll mark it in just to remind me which angle we're trying to find. And then I'll label the two sides. Compared to that angle, this one is opposite. And compared to that angle, this side is adjacent. Say the magic word, SOHCAHTOA, and that'll reveal that opposite and adjacent must be this ratio here, the tangent ratio. So I'm going to use the tangent ratio. And I can see that the tan of this angle at A, I'm going to say the tan at A, is equal to the opposite over the adjacent. So the opposite is 4 and the adjacent is 3. Now, I want to work out this angle at A. I don't want to know the tan of the angle at A, I just want the angle itself. So what I'm going to do is undo this function here. I'm going to do the opposite. So to both sides, I'm going to find the inverse tan. So that's got rid of the tan function on the left, and that inverse tan has appeared on the right. So can you see this is a little bit different, and we've written -1, which indicates that this means the inverse tan function. So now when I go to the calculator, instead of pressing the tan button, I have to press the shift button and then the tan button to give me that inverse tan function. But then, using the little fraction template here, I can type in 4/3, or you could just type in 4 divided by 3. And then I will close the brackets and then press enter, and it's given me 53.1. So the angle is equal to 53.1. That will be in degrees, of course, and the proper name for the angle is CAB. So I'll put that here, and then I'll look at the diagram and see if it sounds reasonable. Yeah, that could be about 53.1, even though the diagram isn't drawn to scale. So that is my answer, and that is to 3 significant figures. For this question, we have to find the angle ACB. So that's the angle at C in this triangle. I'll mark that there. And I can see that these two sides, compared to that angle, that one is the opposite. And this one, the longest side of the triangle, is the hypotenuse. So, opposite and hypotenuse. SOHCAHTOA, the magic word. Let's see what that reveals. Opposite and hypotenuse, I can see over here, it's the sine ratio. So I can write down that the sine of this angle, I'll just call it C, is equal to the opposite over the hypotenuse. The opposite is 6 and the hypotenuse is 11. We don't need to write the units, they would in fact cancel each other out anyway, but 6/11 is the ratio, the sine ratio for that angle. So now, in order to find out what the angle is, we do the inverse sine of both sides. And then we go to the calculator. So I'll go to Shift, Sine. That gives me the inverse sine function. And then 6/11 can be done as 6 divided by 11. I'll close the brackets. And I've got an answer of 33.1. So it's equal to 33.1 degrees. And that is what we've been asked. That is angle ACB. And check on the diagram to see if it seems reasonable. Yes, and that is to 3 sig figs. Here is a real life problem about a tree, the height of a tree. And it says the angle of elevation, that means the angle that you have to look up at to see the top of the tree, from this point, 30 meters from the base of the tree, is 32 degrees. And we have to find the height of the tree. So can you see the tree makes the third side of a right angle triangle? The right angle would be down here. That would be the side, and the angle, the right angle, would be there. So we can use trigonometry. So there we have the angle. Here this side is the adjacent. What we're trying to find is the height of the tree. So I'll call that H. And that side is the opposite. Opposite and adjacent. SOHCAHTOA. What is that? Opposite and adjacent. It's the tangent ratio. So the tan of the angle, the tan of that 32, is equal to the opposite over the adjacent. So the opposite is the height of the tree. The adjacent is the 30 meters. I'll multiply both sides by the 30. So 30 tan 32 degrees is equal to H. And then I use the calculator for working out the height of the tree. So does that seem reasonable? An 18.7 meter tree? Yes. Even though the diagram is not to scale, I think that's a reasonable answer. The final example, Tasmin walked 30 meters from the base of a flagpole and noticed that the angle of elevation of the top was 54 degrees. Let me do a quick diagram, very rough diagram of that. It's a right angle triangle. This is the flagpole here. Then I'm going to draw the flag flying from the top of the flagpole. And she noticed that the angle of elevation was 54 degrees. I'll put a 54 in there. Having walked 30 meters from the base. So that's 30 meters. Now she then walked a further distance in the same direction until the angle of elevation was 44 degrees. How far is she from the base of the flagpole? Right, well, let's call that D, that distance, because it doesn't tell us in the question how far she walked on the second occasion. So I'm going to break this down. First of all, I'm just going to look at this right angle triangle here, and I'm going to work out the height of the flagpole. So let's see. The tan of 54 is equal to H over 30. So H is equal to 30 tan 54 degrees. So H is equal to, and I've got an answer, 41 point, and this time instead of rounding it, because this is not my final answer, it's a number I'm going to use in the rest of the calculation, I'm just going to write down 291 ... just to show that it goes on and on forever, and hopefully I can use the whole value in the rest of the calculation. So now I'm going to look at this big right angle triangle here. I now know the height, and really I want to know this whole distance here. So can you see that in this big right angle triangle, the tan of 44 degrees is equal to the opposite. That's the height, which is the 41.291, whatever that is on the calculator, divided by 30 plus d. That is the adjacent side of this big right angle triangle. Okay, I'll multiply both sides by 30 plus d, and at the same time I'll divide both sides by tan 44. So I've got 30 plus d is equal to 41.291 ... over the tan of 44 degrees. So 30 plus d is the answer that we want. How far is she from the base of the flagpole? That is 30 plus d, so that's the answer that we want. We've just got to do this calculation on the calculator. Now can you see that that number is already sitting on my calculator? So all I need to do is do divide, and that last answer is being used now, and I'm going to divide by the tan of 44 degrees. So 44, close the brackets, and I've got 42.8. So the distance that we want is equal to 42.8, and we're working in meters. It does look as though that's a reasonable answer, but of course we've got to our final answer. We've rounded it to 3 sig figs.
Finally, you really need to know these 3 trigonometric ratios really well. The sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tan is the opposite over the adjacent. Sokotoa. Enjoy doing the online exercises. Don't forget to claim your trophies. Then explore all the other parts of the Transom website. Every day's a school day. Bye.
You can find Transom Mathematics at www.transom.org, where you're welcome to use all of the activities absolutely free. Or jump in with both feet and become a Transom subscriber.